Hello, everyone, and thank you for joining us today for this webinar, where today we'll be looking at how to automate infrastructure as code security with HashiCorp's Terraform Cloud and Snyk. My name is Connor Beechnell. I'm on the marketing team here at HashiCorp, and I'll be your moderator for this session. And today I'm delighted to welcome two excellent speakers. First up, we have John Bowero, who is a partner solutions engineer here at HashiCorp. And today he's joined by Paul Harland, Partner Solutions Architect at Snyk, and they'll be your presenters today. So before we get started, I'd just like to run through a couple of housekeeping items. Firstly, we have about 15 minutes at the end of today's session for Q&A. So please ask your questions in the chat as we're going through, and we'll answer those at the end. This session is also being recorded, and we'll send that out to everyone along with the slides that you see today within the next 24 hours. So with that, I'll hand it over to John and Paul to walk through the agenda.
Wonderful. Thank you, Connor. Can everybody hear me all right? See me all right? I hope so. Again, my name is John Bowero. I'm a partner solutions engineer with HashiCorp. I've been here almost 5 years now. And maybe you're familiar with our 8 projects that we have, Terraform being one of the most popular of them. So I'll cover a little bit of the background of Terraform, basic Terraform concepts. Also, the best practices for secure environments in Terraform Cloud. If you're not familiar with Terraform Cloud, I'll show a brief demo and explain a little bit how that platform layered on top of the open source Terraform works. And then again, we'll cover a combined demo that Paul will show with Terraform Cloud and Snyk put together, which is actually a pretty interesting feature set. All right, so again, if you, if you're a DevOps veteran and you move to cloud, we have this anti-pattern, I like to say, move fast and break things, right? We're here to make sure that you don't break things and yet still move as fast as you can. And in this case, we're going to focus on doing this securely. Okay? Obviously, when things really break or when things get compromised, potentially by an unintentional commit of some secret or some sensitive variable to a GitHub repo or to some shared environment, we run the risk of blowing the budget, being compromised with the company, having fines by regulatory commissions, all kinds of issues that we want to minimize the risk of. So we have this really fork in the road, simple concept of 2 products, really, Terraform Cloud and Snyk. And again, you don't have to choose one or the other. Why not both? So they work together very well. In fact, if you've never seen Snyk, if you've never seen Terraform, to see them both together, I think is a great reinforcement of both products' use cases, right? So DevOps best practices using Terraform. And again, Terraform, if you're brand new, is a tool, open source tool that you run as you need to interpret some Terraform code, to decide which providers, which integrations your code is trying to talk to, what cloud providers, what hardware devices, and then make that a reality. It's a domain-specific language or desired state language. Right? Now, the best practices for doing this securely, obviously, if you're an individual, maybe you don't think you need to worry about security, but once you hit collaboration, once you have multiple people working on a single code pipeline or DevOps pipeline with Terraform, it becomes apparent that you need to follow these tenets, right? So centralized provisioning workflows for all teams. And again, if you have 20 different groups all doing their own thing with open source Terraform, it becomes apparent that people need to have a shared central point for those pipelines to run, for the state history, for an audit trail, for complete, responsible, and accountability platform, right? But number 2, implement the principle of least privilege. So we'll show a little bit later about how different teams can be restricted to different feature sets or different resource types. Okay, and that should be done, right? That is a practice. That is not a feature that you flick a switch and you magically have. This is something that you need to plan for. Okay, 3, enforce keeping it dry with the system of record. Again, there's a full audit trail of every state, every plan, apply, who triggered it, whether it was triggered by automation or by a user. That all has to be recorded so that you can find out where things went wrong or troubleshoot. Okay. Four, use code scanning to prevent misconfigurations, right? Now, this is where Snyk comes in strongly, right? Well, Terraform Cloud has a basic governance layer called Sentinel that's able to allow you to restrict certain things being put into practice or into the apply, but it's not going to take an overall look at your code in a way that Snyk will, and we'll see how that works, right? They work both together very well. So again, when I have more teams, more collaboration, more complexity, I have more to worry about and secure, right? I may have a team that is contributing to a hybrid or a multi-cloud approach. Suddenly, one code error or one compromised credential results in 1,000 Bitcoin miners on the company budget, right? That's not okay. So we want to prevent this. We want to minimize that attack vector and that attack surface. So instead of having those teams do their own thing, have their own Terraform code, their own Terraform plan and apply that they run, we centralize that with Terraform Cloud. Right? Now, the analogy, again, for Terraform Cloud versus Terraform open source, think of it as Git and GitHub, right? So Git is a command you run when you have code. Terraform is a command that you run when you have code. GitHub is the platform, the SaaS platform around that. And also they have GitHub Enterprise for on-premise. We have Terraform Cloud as the SaaS platform around Terraform open source, and also the Terraform Enterprise offering if you need to have a private environment in either a private cloud or in your own data center or air-gapped network, right? And again, this is sitting in the middle between multiple users, between multiple collaborators to provide that automation. Users approve a code merge, suddenly that triggers a Terraform run. A run in the Terraform Cloud sense means it consists of a plan, an apply, potentially checks in the middle. So cost estimation, maybe we'll take your plan and put it through the Cloud API to see how much that should cost. And also the Sentinel layer, right? The Sentinel layer, I said, where we're checking for compliance and governance based on code that you provide. Now, we also have run triggers and events that you can insert in between, and that's where Snyk fits in. So we'll see that later. Okay. Again, the best practice for code structure, this always tends to be a question I get from the partners that do Terraform regularly. Do I have one repo that results in multiple workspaces? Do I use modules, which are reusable bits of Terraform code, almost like functions? How do I break up my code? And we find that often the best way to do it is one code repository per workspace. Workspaces can be redeployed multiple times based on different variables using the same code, which is very handy. Okay. Also, we provide RBAC on top of Terraform Cloud, right? So who is able to view states? Who's able to view the output from an apply? Potentially, you may have one organization, again, using separation of duties. You may have a network team or security team that's in charge of security groups, firewall rules, TLS certificates, etc. And they export those, right? They put those as outputs in a workspace for the other teams that need them to consume them in a read-only way, right? This can all be controlled with RBAC. Right? So each workspace can look up other workspace outputs without modifying them. That's the important part. So we have this read, plan, write, admin concept. And also a single sign-on option as well. So if you have SAML as part of your single sign-on strategy, SAML 2.0, we can do single sign-on as well. Now, again, it's fairly granular. Can I manage policies? Can I manage the private registry? I mentioned where you can publish your own private modules. If somebody needs a 3-tiered application that has a custom database, 2 application servers, and maybe a load balancer or ELB, I can have that all packaged up as a module, right, and published to the private module registry for my Terraform coders to consume. Now, I can also do providers. This is a fairly new feature to have private providers in private registry. So you can have your own binaries or tools that you need to use or integrations with third-party solutions available for yourself to consume by a private registry. Okay. Now, again, there's the private registry for preventing, again, minimizing the attack vector, preventing unwanted modules. Maybe someone can't just go download a GitHub module and apply it without, or deploy it without actually checking the code to make sure it's doing something nefarious. And then Also, we have that Sentinel policy on top, right? So I can A, restrict people to only using modules from a private registry. B, I can have a generic policy as code framework using Sentinel, which is actually a separate project that we maintain, HashiCorp, that we combine with a lot of our enterprise offerings. So things like certain API endpoints are only available based on a programmatic lookup of another service or time of day or change freeze maybe, right? Now, this comes in very handy for Terraform to step through the plan and say, this is using an image that's not approved, right? You can write a little bit of Sentinel code, and I'll show an example of this in a second, where people are prevented transactionally from deploying something that is not allowed. HCP Packer is a kind of a HashiCorp Cloud Platform, is a managed instance platform or SaaS offering that we have. We include a couple of our products on it. So if I want to one of our Vault instances or a console, another product of ours, I can have that deployed and supported automatically by the HashiCorp Cloud Platform. We also have Packer. And if you're familiar with Packer, or if you're not familiar with Packer, Packer is image maintenance and management tool, right? So I have maybe 5 different cloud regions and 3 different clouds, and I need to make sure that my images are consistently deployed across all of those. I can do that with Packer, which again is a purely open source tool. It's free to use. People use it in production and enterprise. And then have HCP Packer registry keep track of the metadata for those images, do lifecycle management, retire images that should be deprecated, give an image ancestry tree, say images that are inherent from each other, and manage the actual complex environment of having multiple regions, multiple clouds, multiple images to maintain. Now, Terraform can be used to look up those images, right? So same deal. I can have a policy in Sentinel to say, do not allow an image that's not coming from an approved registry. And I also have the option to use variable sets now to maintain sets of credentials, sets of variables that are going to be global for an organization. And it sounds a little funny if you've never seen Terraform Cloud before. I will show that in a second. This is a screenshot of the registry in Terraform Cloud as we see it today. Again, there's providers and modules. Now have the ability to synchronize a public module. So if I'm using GCP or AWS, and I see that there's a module developed by AWS that I want to bring into my own private registry, I can synchronize that easily. Same with providers. I can actually browse some of the public providers that we have. If I need a custom integration, have that synchronized into a private registry as well. Sentinel, again, can enforce usage of approved modules in production environments, preventing misconfigurations in the first place. This, again, is transactional, right? This happens during the actual plan. And Snyk is going to provide an additional layer of that code analysis via the actual VCS. Okay. Again, HCP Packer will help you prevent outdated images from lurking in your stacks. Nobody wants to redeploy a Terraform module and suddenly find that they've got a 4-year-old Linux image that's got all kinds of vulnerabilities and that should not be out there. Right? So we help you manage that lifecycle automatically with HCP. Terraform Cloud, again, can enforce compliant image usage with image compliance checks. So again, this is a sample task. HCP Packer 0 passed, mandatory. This is in addition to Sentinel, actually. I will show this interactively in this other tab here as soon as I can finish this. Okay. And again, credentials or variables that should be spread across an entire organization. We have that variable sets. So again, one of the hardest parts of Terraform tends to be that people need to define credentials or cloud credentials in multiple places or in Group Workspace. And then it's a matter of time before somebody accidentally commits them to GitHub or to somewhere public. And I fully admit HashiCorp employees are guilty of this as well. We've done this ourselves a few times, right? So it's helpful to have an additional tool to scan and make sure that you cannot commit certain things to code in the first place. That's something that Terraform lacks, right? Terraform will allow you to prevent merge of something that breaks a Terraform policy or a Sentinel policy, but it's not going to prevent you accidentally committing a secret to that code in the first place. Okay. So again, an ounce of prevention is worth a pound of cure. And let me, before I pass off to Paul, give a brief tour of Terraform Cloud. And this is actually using our new interface, our new theme that the Terraform team is rolling out. Should be generally available fairly soon, I believe. But you can see that I have a multi-tenant approach in Terraform app.terraform.io, which is the Terraform Cloud SaaS endpoint. Remember that if I use the free tier, just like GitHub has a free tier, Terraform Cloud has a free tier. Users are free; anybody can sign up. Right? The feature sets and enterprise features, which are available to purchase, are based on the organization. So just like GitHub, I have a free GitHub user. I can see all kinds of repos and be part of all kinds of organizations. And then it's up to the organization to purchase additional features. Right? So if I take a look at my own organization here, I have multiple workspaces that I've used for demos or potentially for workshops that we've done. And again, if I'm a financial organization and I need to have a full audit trail of all these histories, runs, the applies, all of that's there, right? Again, this is basically sandbox, right? It's just myself. If I go back to the organizations, it's much more helpful to see a collaborative environment. And down here, I have lots of partner organizations that I'm members of, but in here, so many, there we go, so many organizations that I can't even find the one I want anymore. This is the one used by our team frequently for demos. And I can see again what my team is doing. If I'm a manager, someone did an AWS demo stack deployment, and I can see that they did a destroy, right? So again, if you're new to Terraform, Terraform has the plan, basically, which is a build. Go out and detect if there's a state. So if I already had something deployed with Terraform, if not, create everything new, right? And as that is applied, as I take that plan and put it into action, do the apply, that state is generated based on what Terraform did before. Right? So that Terraform has the ability to go say, okay, I need to change what's out there, or I need to destroy what's out there, without messing with other people's resources. Right. So now again, I have this 4+ stage pipeline. I can see that this was triggered from the CLI. The plan finished. I have the plan output here. I have the cost estimation again, which is available for the 3 major cloud providers. And remember, I can create a policy based on this. And in this case, I have a mandatory tags enforcement. So I cannot actually apply a plan that doesn't have a resource, that has a resource without tags. Right? I need to define certain tags, maybe owner or TTL or time to live, so that a bot can purge it, right, if it's not being used. And then I have the output from it. Right? So again, the run triggers are able to insert additional steps in here, and that's what Paul will show you with Snyk. So again, we have regular workshops with Terraform Cloud that are, again, free for anybody to do. If nobody's seen this before, I suggest you sign up. Again, the free feature set covers minimal usage of collaboration and exploring how to use Terraform. All the other features, the Sentinel and the advanced enterprise features are fairly simple to purchase. Right? So let me hand over to Paul actually for the more interesting demo, combining what you just saw in Terraform Cloud with Snyk, and then we'll do a Q&A afterwards, if that makes sense. All right, so let me stop share. Paul, are you there?
I am indeed. Thank you very much, John, and ready to go. Sad to say, I'm working off the old UI. I've not got access to the new one, new shiny one that you had. But here we go anyway. So let me give you an introduction into Snyk. I believe you can now see my screen. So what is Snyk, first of all? Well, it's an application security platform, a developer-first application security platform, which means everything that we've done in that platform is around developers being part of the security effort and security team within a DevOps or DevSecOps environment. And we look at a few things to do with modern applications. So we look at the code that the developers are writing, the open source code that they use and leverage in that code that they're writing, the containers that gets deployed upon, and the infrastructure as code as well. The reason why we needed to make this platform is that we've moved to this new era where people are now deploying on the cloud. And that has changed the way apps look. Now, that used to be you'd write some app code, use some open source, then everything else really would be left to the IT and operations team. But that's no longer the truth. We're now deploying on the cloud. We're now deploying much more regularly. So in order to be able to get artifacts or versions of the application ready, in order to go live, we actually need to start doing some security earlier. And when we're moving from pre-cloud to cloud, we've also got a kind of change in the way developers work, the number of skills they need in order to operate in a modern application development team. Now, things like the containers, things like the cloud infrastructure and cloud services that they use are all built inside the Terraform. No longer hardware appliances, servers and WAFs on the front end. They're no longer hardware. They're now configured into that Terraform. And the developers have had to pick up these skills and start learning what were traditionally IT and operations skills. Now, we all know with great power comes great responsibility. So when developers are learning these new tools, they need help in order to make sure that the decisions they're making have not introduced vulnerabilities to the code. And that's what Snyk's allowing to do with the platform and the shift left mechanisms, which mean we're allowing developers to take part in that security effort. So just roughly, what does Snyk do? Well, as I mentioned before, we look at the code that the developers write. So we've got a static analysis tool, a next generation static analysis tool, which allows developers to scan the code they're writing, either on their local machine in the UI, or even pull requests that are created as well, to find vulnerabilities that they may have inadvertently added. We also look at the open source, and this can take up to about 80 to 90% of the lines of code in a modern cloud app. Now, we all know that open source ages like milk, not wine. So the longer you leave it, the more stale it goes. So you need a scalable tool that's always looking at the open source, that's always showing you when vulnerabilities have been found or when you've introduced new vulnerabilities. And that's what Snyk can help with as well. We're also looking at the containers that the artifacts from the code and open source get deployed upon. Now, developers, again, they're not traditionally great or experts, should I say, in terms of choosing the right container and the right packages to be loaded on. Containers themselves go stale with the open source packages on there. So we're helping developers choose the correct base image, keep that up to date, but also showing them vulnerabilities on any user instructions that they've added as well. And then down at the bottom, infrastructure as code. Now, this is where we're deciding what that infrastructure looks like, how it should scale, how the microservices and containers should interact with each other. And this is where this cloud configuration is where a lot of vulnerabilities can get introduced into a modern app. And this is where we're going to concentrate the demonstration and hopefully questions on today. So how do we kind of work across this DevOps pipeline or SDLC, however you want to name it? Well, what we're doing is we're helping the developers shift left and do this work early on by integrating into the developer's workstation, either the command line interface or IPE integrations. But you know, a lot of people also have legacy code, also want to commit that code in collaboration tools. So we also integrate into the Git repository or the common SCM tools that are out there as well. And then the CI/CD pipeline, which we'll kind of show you today in an example, we can start to either report on vulnerabilities that are found, or we can actually fail builds. And these builds can fail based off new vulnerabilities found, policy changed, or even just code that's been added that's got a new vulnerability. And then we're also monitoring that live production cluster as well. Have any new vulnerabilities been found on the code or open source that's on those live clusters? So that means that we've got quite a few users of the platform, really. The developers like to remove vulnerabilities before they've even been added to the Git repository. But then we've also got the DevOps, DevSecOps teams who are monitoring those live clusters and need to kind of understand what that security posture is on there and pass some work back to the developers, or even the developers, better still, finding it early themselves. Okay, so there's a few things to know about the integration here with Snyk and Terraform. Terraform Cloud, is that Snyk is allowing you to look at that Terraform plan before it goes live and either find the vulnerabilities or prevent that vulnerability actually going live. And we're also integrated, and as John was saying before, it's in that Terraform Cloud business. So we do have run tasks that are already built in there, and they're quite easy to configure. I'll go and do that right now to show you how we do it. Okay, so just to give you orientation into the Snyk platform. As I said, it's very developer focused, so you will only see the projects that you're interested in. Now, if we use this top drop down here, you can see I'm a member of many organizations, and within those organizations, I'm a member of many projects. Hopefully you wouldn't have so many things to look at and you just see the things that you are interested in. And then once you go into one of these organizations, you'll see a list of repositories or scans that have been completed against your application. Now we've got kind of two different ones here. We've got GitHub integrations, and we've also got what are snapshots which have been sent across from Terraform Cloud so that we can view them in the Snyk console as well. Now, if we have a look at one of these projects, this is called Goof. This is one of our intentionally vulnerable apps. You can see that we've actually done a scan down each of the layers that we mentioned before. So we've done a code analysis, that's the static analysis scan, and we've found some vulnerabilities. We've also done 2 open source scans, so we've found 2 package.jsons, because this is actually one of those mono repos John was talking about, with the front end and the back end in one repository. And here are the number of vulnerabilities we've added here. If we look at the Docker file, again, even before we built the container, we can scan the Docker file to look for those vulnerabilities. And we've found 2 different styles of, or 2 different types of infrastructure as code, a deployment.yaml and a CloudFormation script here. And then if I wanted to set up the integration with Terraform Cloud, I'd head over to the integrations page. And this is where we'll load all the different integrations that we can have set up. The cog icon here refers to the fact that this is already set up and I can go and change the settings. So we've got source control tools, container registries, and CI/CD pipeline type integrations. If I wanted to set up Terraform Cloud, I would click on that. I would see my URL and my HMAC key. I would copy those across, then go over to Terraform Cloud, into the settings, and then into run tasks. These are the run tasks that I have already got set up, and these are the integrations I could choose from. I can choose a new Snyk integration, but here I'm just going to go and edit an existing one. Within that, I can then add my URL and my key. And then that integration is set up and I can make it available to all workspaces as well. Now, over in Snyk, I can decide whether or not that is going to stop builds based off severity or threshold severity of vulnerabilities that I've found, and I can choose high, medium, or low. Once you've done that, it's then a case of choosing your workspace. Here you can see I've got one called Learn RDS, and then going to add that run task in. You'll see here I've already got the run task added. If I want to add new ones, I can click on the plus item and add those. Then any future runs within that workspace will include that task. Very simple setup, easy to do. I advise you to go and try this on your code within Terraform Cloud now. Okay, so just a brief overview quickly of where we integrate. So if we're talking about looking at Terraform Cloud code and removing vulnerabilities, we can integrate into the IDEs. We can integrate using CLI tools so that you can script it, get pre-commit hooks, things like that. Also within the repositories that we're running as well, and the pipelines where we can actually fail builds or just give notifications of vulnerabilities, again, based off the policy that is set up in Snyk. And we've got that Terraform Cloud run task as well. Okay, so let's look at an actual example. Today we're going to look at this example, which is Learn RDS. Let me just show you this. It's an open source project maintained by HashiCorp. And all it does is deploy a simple RDS Postgres SQL database onto AWS. Very simple, but it gets the point across. Now, it's not typical of a normal project because there are only Terraform files in there, no application, no open source, no containers, things like that. But as I said, it does get the point across. So what do we do in order to actually scan and look at the results of one of those runs? Well, very simply, if we go over to Terraform Cloud and we look at our runs, we can just set a new run in action. Now, I'll leave that run in the background, but what we'll actually do is look at one of the previous runs and you can see the information that you're getting from that. So here we've got one send live that we did 19 hours ago. Let me go and click and look at the tasks that have happened there. So as John was showing you before, what we've got is the plan generation, first of all. And we know the plan's generated. We've got a few warnings, but we're going to continue with this demo. Once the plan's then generated, that's where Snyk hooks in and says, okay, we've got a plan. We understand a lot about this code. Are there any vulnerabilities against that policy that we've held for our infrastructure? And we can see it's failed. It's still on advisory. So this run has actually continued. When you first do this integration, you might want to just be on this advisory stage. This allows you to understand if there's any vulnerabilities, but doesn't stop the builds. Once you're at a certain level of vulnerabilities that have been removed, you can then make it mandatory and any future builds will fail. And this has the added advantage of if your compliance or security team change that policy, all future builds will then fail. And you can even see that same policy change on your local machine. But what is the advice that Snyk has found? So we've got 1 high severity, 4 medium, and 4 low. And if we click on the details, we can go through to see that. So here you see the resource is publicly accessible. It's non-encrypted. Backup is disabled as well. We've found quite a few items against the current policy, which means this would have failed if it was mandatory. So what's the kind of real workflow here? How do developers go about fixing this? Well, they wouldn't edit the plan or change the plan. They'd look back at those original Terraform files in order that they can then fix that in the plan, once the plan is generated, sorry. So we would go back to our projects as a developer. We would find the original Git repository where this was, and we'd see these vulnerabilities in the original Terraform as well. Now you'll notice we did actually have an extra vulnerability in the Terraform plan that isn't evident in the main Terraform files, but we'd use the information from that plan run to transpose it back to the original project. But what we're getting here is the problem is a non-encrypted RDS instance at rest. But Snyk's all about prioritization and remediation. So we also help the developer understand what the problem is. So here's the issue. The DB instance storage is not encrypted. The impact of this is that someone could gain unauthorized access. How can it be resolved? Well, we can set storage encrypted to be true. So I would now, as a developer, open up my IntelliJ and, oh, by magic, I've already got this project open. If I look down now, you can see at the bottom, hopefully you can see this, it's not too small on your screen. I've already scanned this application and you can see that same vulnerability actually there. So we've got non-encrypted RDS instance at rest. I'd use this information. I would go and fix this. If I could spell it right during a live demo, that will be amazing. Once that file's saved, I can then scan that. That vulnerability will then have gone. I can then commit that to the repository. Terraform Cloud will pick up that change and automatically it will kick off another build. And then hopefully I'll be able to get through to live. Obviously, you can see that there's more vulnerabilities here. But just incidentally, I talked previously about the policy. If we go back to Snyk now, and I apologize for all these tabs switching around, you know how it is when you've got multiple open. I can go into my infrastructure as code policy, and I can see all the items related to the different cloud providers. So we've got Terraform available on AWS, Azure, GCP, and Kubernetes configuration as well. So if I go to AWS and look for the RDS items and actually change the policy for one that we've found, so RDS, I am authentication disabled. And if I change that policy now to none, this could be, you know, my security or compliance team making this change. Me as a developer on my local machine would also see that reflected, and I'll no longer get that issue showing up in the scans on my local machine. Incidentally, that would also happen in Terraform Cloud. We would mark it against the current policy, and that would decide whether or not that actual build would pass. Now, that's not the usual way things would happen. Obviously, you get more rules being added rather than things being removed as new vulnerabilities get found, as new methods of securing these cloud services and new cloud services get added as well. So what would happen usually is once a build is going through, a policy change would happen to fail that build. That means all future builds would need to change before they can go through. And in that way, you can ensure that all of your infrastructure managed by Terraform and managed by Terraform Cloud is compliant with the current policy. And that's generally how we work together to ensure that we're pushing through the correct infrastructure as code that's marked against policy in that scalable, automated way. We no longer need to have to do these manual checks. We've got the tools that can help us at every stage of the way. And just to show here, you will be getting these slides later. If you want to have a look at all the rules that we have around Terraform, there's the URL. Obviously, you can sign up for a free account as well and go and look at the policies how I showed you just previously. In fact, we've got some simple instructions how you can onboard and try Snyk with Terraform Cloud. It's as simple as signing up to the free account, enable Terraform Cloud integration Snyk, and then set up the Terraform Cloud run task. What we've also got, incidentally, are some simple demonstration repositories from HashiCorp and Snyk that will allow you to test these concepts before you push them into your live or production repos. Sometimes it's all about learning what the best process is before we deploy it or before we introduce our teammates to this way of working. That way you can always answer the questions and kind of be the shining light in terms of the new way of working. Okay, that's everything complete today. Let me do the thank you slide. Are there any questions that we've got so far in the Q&A?
Absolutely, we've got a couple that have come in. So just starting right from the top, John, probably a question best suited for you to start with. What happens if a developer uses the Cloud API to change the resource in production after the Terraform plan has been deployed and that introduces a misconfiguration?
Okay, interesting. So let me paraphrase this for people who haven't used Terraform Cloud. So you have workspaces, right? Workspaces can be attached to a repo. You can have many workspaces to one repo and then have variables different between them. Now, yes, so you can rerun or change Terraform workspaces with variables without changing the code. Yes. Now, the good thing is the Sentinel policy still takes effect, right? So if you have a variable for cloud region, maybe, and then you switch that region to say, I'm going from Europe East to US West, and then do an apply. Terraform will logically say the plan is I need to destroy Europe and rebuild it in the US, right? If the Sentinel policy is still there to say that allowed regions don't include that, Sentinel will block that, right? So it doesn't matter if the code workflow is having a different effect, right? The Sentinel will still block that. But yeah, similarly, if you change that via code, Sentinel will block that as well. But as far as Snyk integration goes, I don't think, actually, that's a good question for Paul. I don't know how that would affect the Snyk side. I know that the Terraform workflow would still capture that with Sentinel policy check. The post hook, I think, would still be in effect as well. So Snyk should still be able to enforce that too. Okay. I hope that answers the question correctly. Somebody, if not, feel free to ask again.
Fabulous, thank you, John. And Paul, probably one more directed to you now. The cloud providers are constantly adding new services. Will Snyk continue to reevaluate the list and coverage of the rules?
Yeah, absolutely. We do evaluate the rules. We also allow customers to generate their own rules as well. We're working on ways that people can add their own rigor rules into these kind of scans. But yeah, absolutely. If there are rules that aren't there at the moment, we can speak to our support to get them added. But we're looking at ways where actually people can manage their own policies and therefore severities around those policies as well. Then you don't have to rely on us.
Fabulous, thank you. Another one is there a plan to integrate Snyk with Terraform on-prem?
Yes, I saw that one. Now, again, Terraform Enterprise is the on-premise version of Terraform Cloud. It shares a lot of the same code base, but not all of it. Now, I'm pretty sure that they're intending to do this. I can't give a date or guarantee when it will arrive, but I'm pretty sure it is in the plan to support eventually. And also Terraform Cloud, Terraform Enterprise, the on-premise or private installation of Terraform, which is popular in Europe, is being re-architected to have a much simpler deployment right now. Typically, it is deployed on a VM with a custom orchestrator. And in the future, we may have, the team in charge of that is trying to make it a simple Helm chart or some orchestrator that will deploy Terraform Enterprise for you. So that will make the code base a little easier to maintain across Terraform Cloud and Terraform Enterprise. My short answer is yes, I believe so, but I don't have a guaranteed date or timeline for that.
Okay.
Yeah, it's planned, but not on the roadmap for delivery yet. But yeah.
No problem. All right. The next one is it possible to do the remediation from Snyk site instead of doing it on a local machine?
If we talk about open source, then we do automatically create pull requests, and we can manually create pull requests to fix that as well. However, if we talk about infrastructure as code Terraform, there's no current pull request mechanism. Now, we did, kind of look at things like this, and there are some simple things that we could perhaps do with pull requests, but a lot of the changes require parameterized changes, such as adding a memory limit with a value. So really, what we looked at is actually what's the developer workflow there? Would they want to do this from the UI, or are they going to see these problems in the IDEs anyway? And generally, we're seeing that the scans are happening in the IDEs or the local machines, and the developers are making the change and committing this through the normal Git commit process. So I don't think there's a plan to add IAC remediation in the UI in the short term.
Okay, thank you, Paul. A lot of questions here, which is great to see. The next is, how does Snyk define the severities of high, medium, or low? Yeah, so they're defined, first of all, by our security team, who are kind of experts in this space, deciding which one opens up certain vectors of attack, which ones are most critical. But also, we're speaking to our customers as well. Now, bear in mind, these are just the default severities, and you can go and change those yourselves. But we think they're sensible defaults, and we'll continue to maintain that list based off our beliefs there. Okay, thank you, Paul. How does Snyk help in, say, UAT or production environments once the code vulnerabilities are already found and fixed in dev? So what we do when we're in any kind of live environment, whether it's UAT or actual live, we can continue to scan that application because we take a snapshot during the CI/CD, which means we understand whether you've tagged it as a version or whether you've tagged it as a release. We can continue to scan that snapshot to understand, have we found new vulnerabilities? Because it might be you've removed all the vulnerabilities and then you've released. Overnight, 3 or 4 new vulnerabilities can be found on the open source packages or the container that you're using. So we continually monitor that, and then we let the developer know this version or this tag that's live has these vulnerabilities. It's related to this repository. You go and fix it, and then you can redeploy the fixed version as well. So it's all around not fixing what's actually live, but fixing the code and then redeploy it live again. Okay, fabulous. Does Snyk check in cloud runtime for misconfigurations?
So at the moment, we don't check in the runtime for cloud misconfigurations. We are adding a new Snyk cloud product, which you may have seen the release or the blog post about, which will then move into that CSPM space as well and allow people to look at things like misconfigurations or drift within their live cloud applications, but still relating that back to how the developer should fix it. We call it code to cloud to code. So our code is being deployed into the cloud, but then the fixes need to be related back to the code that the developers write. So we're always trying to think in the context of the developer, how do they fix this misconfiguration or drift?
Okay, fabulous. Last couple of questions here. John, probably one for you. Is Terraform Cloud a hard requirement for this integration?
Yes, so the actual integration is done with Terraform Cloud, and the support is obviously by Terraform Cloud. I'm pretty sure that Snyk could be custom tailored with a custom pipeline, or have an integration with something like Jenkins or GitLab or some other automation that could be potentially used with Terraform open source. I don't know of anybody doing that, but I'm guessing it's probably feasible.
Okay, thank you, John. I said last couple, a few more are still coming in. Paul, do we need to upload our code to Snyk Cloud when we use Snyk? If so, how do you guarantee intellectual property?
Right, yes, so when we are a SaaS platform. When you scan with Snyk, you're uploading your code. Now, when you talk about intellectual property, that's not usually the Terraform or the containers or the open source manifest files. That's the Snyk code, so the static analysis solution. So I'll answer it in terms of that. So yeah, we do upload your code. We turn it into something called data log, which is an interim language where we do the analysis. Your code is then removed, but with links back in that data log to the file and the place in the file in GitHub or GitLab, wherever that code resides. So yes, we do upload it to do that analysis. We then remove it. Incidentally, we do have a kind of web page which shows you how we deal with your data, how we dispose of your data. And what I'll do, I'll make sure I add that to the links in the presentation that we're going to hand out, so that you can read all about that as well. If you give me 2 secs, I might even post it in the chat.
Amazing. And this is the last question, I believe. Is there any best practices on how to automate remediation process after a policy failure has been discovered?
Do you want to take that one, John, or me?
Yeah, sorry. Ironically, there's 2 questions here that talk about policies and are not specifying which product. so there was also another question about how many policies are provided, and that was actually about Snyk policies. If this is talking about Sentinel policies in Terraform, then the best practice is to automate remediation process after a policy failure being discovered. So this is a Sentinel policy failure. In that case, that depends on the Sentinel policy, right? So there is a bit of code that will say which regions are allowed. Again, it could programmatically look up an external service. An example we have is people using Terraform to manage infrastructure for satellites. And they will actually do a lookup on NOAA, the government weather site, to say, is there a solar flare? If there's a solar flare or solar activity, no change is allowed. It's a really interesting use case. And in that case, you can't change it. There's no remediation. You just have to wait for that window to open again. So that depends largely on the policy. Best practice would depend on the policy.
Yeah, and in terms of Snyk, it's not that we automate the remediation process. We're automating the failure of the go live, and then we have process and best practices in place to fix or remediate that. And that's really how we work with individual customers. Is that something where automatically the developer would fix it and redeploy? Or is that something we kind of want to create a Jira ticket around? Or is that something that the security team will handle themselves? So really, we want to understand what the actual process that the customer is using, and then we'll help the customer implement that process along with the platform during our kind of rollout phase.
And Paul, are there any common policies between Sentinel and Snyk?
I think we share a lot of the same policies. We've got a security focus, and I believe the compliance or the way of working in Sentinel is around having auditable and similar infrastructure across. So we're just looking at that security. That's where we're focused. So Sentinel has got a kind of wider scope in terms of that.
Sure. Yeah, I agree. I don't think there's any specific overlap. There's not a Venn diagram that I could point out listing exactly which sets of policies are in common. But there is actually a new, let me actually show this a second. I'll just briefly share one more time. So this, again, I have the ability to, and it's the new UI, so bear with me. The policy sets. Oh, this is the wrong organization. Policy sets should be synchronized. You can actually synchronize them from an external source, right? So we have libraries of policies that we've written either for customers or for examples. And in this case, registry, providers, modules. I can also synchronize policy sets now. So I can actually browse from the catalog of examples we have. This is a fairly new feature and is really helpful because before a lot of people would actually have to go and find their own code or use or copy from a repository of our examples. And now it's quite a bit more flexible. So I can actually browse the list of almost like a marketplace. And if you are curious, yes, I'll drop a link in for all our example policies because we have teams that are now specifically in charge of generating examples and integrations with the other vendors and clouds.
Great.
Right. Now, again, there was one more that was answered at how many policies are included out of the box, and I don't want that one to get ignored. And that was for Snyk. Sorry, that was for you, Paul.
Oh, I don't know a number. Lots. Like I say, that link on the slides will take you to the full list of all of the policy items that we have across the different IAC configurations and across also things like CIS benchmarking or PCI as well, shows you which rules are kind of within those frameworks. So please use that link and I'll try and count them and add that as well. Which is changing all the time.
Great. All right. So a huge thanks to both John and Paul for that presentation. And it was great to see those demos as well, just to show how this is all working in the real world. So that concludes today's webinar. Just a reminder that this session was recorded and we'll make that recording available on our website after processing. I'll send you a link via email once that's ready, probably within the next 24 hours, along with the slides that you've seen today and some additional resources that Paul was referring to. And that will just help you get up and running with Terraform Cloud and Snyk. So I hope everyone enjoyed today's session and thank you so much for joining us. Thank you, everyone.
Indeed, thanks. Thanks for joining and thanks for all the questions.
Cheers.
Cheers. Have a good day. Bye-bye.